Thank you. So I think, first of all, we have to speak about this term, rock glaciers. Just before we visited Perito Moreno Glacier in the presentation by Piotr, which is a real ice glacier, so the one we are used to when we hear the term glacier. Now we look at rock glaciers, and they are not just glaciers with rock on top. They are periglacial features. We need permafrost condition to have these landforms. So the term we are still using, is not really a good one. But since we are used to this term rock glaciers, we keep on working with this. So let's go to the Engadine, which is a key site for rock glacier research. We have these specific continental conditions in the mountains, high elevation, and also high weathering rates, while we have this rock glacier hotspot. So the Engadine is part of the canton of Grisons in eastern Switzerland. We go to this area where we have the famous site of St. Moritz, where the rich and beautiful people go to do their holidays, which is here, and then the Swiss National Park, which is in this area. And we see a lot of these landforms in the area, which are connected. Here you see the geomorphological of part of the Engadine, quite nicely connected to the glacial systems. And here in red, you see several of these landforms in active condition, but also in relict or inactive conditions. We can say that we have several hundred or even more than 1,000 of these rock glaciers in Switzerland, several thousand in the Alps. In every mountain region we find these landforms, and also in polar environments. Everywhere where we have permafrost conditions and loose sediment which can build up these landforms. So the characteristic morphology is given by these steep lateral walls and the front, and also this peculiar ridge and furrow topography, which is indicator for the movement of these features. Very often they start in glacial cirques or also in debris slopes. This is the same rock glacier as seen from above on an aerial image. You again see these nice ridge and furrow topographies. You can see that there are several generations of lobes on top of each other. And here even this outbreak lobe, which are moving, and we see nowadays, we see highest movement rates here in the central part, but even the lowermost lobe is still moving with 20 to 30 centimeters per year. These are the morphological characteristics. When we look into the inside of this landform, we find a matrix of ice and rock. The ice content can differ quite largely. We can have 20 to 60%. We only know this from a few sites, of course. We have a shear horizon for these landforms here. This shear horizon is at 20 or 30 meter depth, where most of the movement takes place. And we have this active layer that is changing throughout the year, so freezing and thawing, the uppermost meters. This is also an insight that we can give from boreholes that we have in these rock glaciers. So we can see, we observe, monitor the temperatures and depth. And you see here the longest series from 1988 to today. And you see the changes in the temperatures and depth. So, of course, a lot of changes in the uppermost meters, but still in a depth of 20 meters, we can measure a warming of about 1 degree. So there's a long scientific tradition which is special for the Engadine. I think the term or this landform was first described in 1910 in the US. And we know of the first measurements from the 1920s in the national, at that time, newly founded Swiss National Park, where Emil Schä and his son started to paint some stones on top of this rock glacier, and they came back every year and measured these stones and how far they moved on top of the rock glacier. So that was the beginning, and then a long history on permafrost science started with Dietrich Bahr from Heidelberg in Germany, Wilfried Häberli, and they all contributed to a lot of insights. Then in 1987, we had the first deep borehole drilled in a rock glacier, and you can imagine that was not so easy in this rough terrain. But of course, there's a cable car nearby, which is the case for most of the sites in Switzerland. So we started with this first borehole, 60 meters deep, and we started with this monitoring series on the site. The borehole is still existing. We still got some data out of it, but in 2015 we had a new borehole next to it to be sure to have a long-term series. This is here on Motel Rock Glacier, the famous one. You can see some of the installations here on top. And this was the starting point of a long tradition in consistent permafrost monitoring, which built up the first national permafrost network starting from 2000 on, with different key variables. So ground temperatures in depth and also on the ground, subsurface ice and unfrozen water content, so data from the boreholes, but also from the geophysics, and velocities of permafrost creep by geodetic survey and photogrammetry. So we have these boreholes here, but we also have continuous GPSs on these landforms, which can show us the annual cycle of the movements. We have distributed networks of survey points to describe the velocities. In addition, we have automatic weather station to describe the full energy balance, and also distributed temperature loggers to observe how the permafrost temperatures are developing. So we have this long-term monitoring network within Switzerland, and especially in this area of the Engadine, giving movement rates by in situ and remote sensing techniques. At this site, I'm going there every year and doing my measurements. We also see that it's important to have this kind of outreach, because a lot of tourists come by while we are measuring, and then they start to ask, so what are you doing there? And then they start to have a look. And with our explanations, they often for the first time see these landforms. We had people saying, I don't believe it, I come here since 20 years, but in former times I only saw these blocks and rocks. And now I understand that this is a landform which is creeping downslope. So also the outreach is important. So the main arguments for the recognitions were that this is a reference place for mountain permafrost monitoring and research. There are several of these landforms, and they provide ongoing process understanding, and also, of course, the related changes that we are currently measuring. So this certificate is not only important for us in Switzerland, for the geomorphologists in Switzerland, or for the permafrost monitoring in Switzerland. It's also important for the entire rock glacier community, as we build a group within the IPA, so the International Permafrost Association, and we just recently became an associated parameter of the ECV permafrost with our rock glacier kinematics, which is quite important at this stage. So merci vielmals, thank you for listening.